Hello everyone, myself Suresh. I'm a second year construction engineering and management student of CEPT University. For our third semester studio, Integrated Construction Practices, a corporate high-rise building project in Gandhinagar has been selected. The scope of work focuses on basement 1 and 14th floor, serving as typical sections for the application of advanced BIM users. Each group member assumed the role of a key project stakeholder, that is, architectural, structural, and MEPF consultants, simulating the process for the selected project. This approach was designed to identify the limitations of traditional construction methods, understand the role of technology in construction management, and highlight the importance of effective communications and collaboration in successful project delivery. An essential component of the studio involved site observations and interactions with various stakeholders at the construction site. These engagements enabled us to analyze challenges and propose solutions using BIM and lean methodologies. The application of advanced tools and technologies enriched the overall experiences of the studio. In this portfolio, we will discuss about Model Element Authority, LOD versus LOS, quantity takeoff, and 4D simulation. Our project is a greenfield high-rise commercial building in Gift City, Gandhinagar, which is of G plus 15 plus 3 basements built for shops and office rentals, with estimated cost of completion of 95 crores. Type of contract involved is item rate. The project was started on 26th May 2022 and expected date of completion is 31st March 2026. Land area is of 2,262 square meters and build-up area is of 21,646.4 square meter. The nearby hotel is 44 minutes away from the location, and its connectivity to airport, railway station, and nearest bus stop is 26 minutes, 29 minutes, and 10 minutes, respectively. Following are the elements considered for MEA of architectural, structural, and mechanical models for 14th floor and basement 1. Given below shows some elements in architectural, structural, and mechanical models and its level of development. In architectural and structural, for walls, doors, columns, beams, and all other elements, both LOD 300 and LOD 400 models were prepared, whereas in mechanical, only LOD 300 is prepared for all the elements. Following here shows the LOD versus LOS table for architectural, structural, and mechanical models with its level of development for each element and week of completion of that element in that model. For example, here for masonry walls, both LOD 300 and 400 were prepared and it was completed on week 7th and week 12th respectively. Following table shows the cost after quantity takeoff from electrical, plumbing, and fire services. First column shows the element category, second column shows the cost after quantity takeoff through Revit, and third one showing the cost after manual quantity takeoff as practiced on site using 2D drawings and on-site measurements. On comparison, it was found out that Rs 37,549.5 can be saved with the quantity takeoff through Revit, which is 0.5% of actual amount as per site. Now coming to the 4D simulation, first it is showing the process flow for 4D simulation in studio using Navisworks. The 4D simulation was made according to 8-week look-ahead plan for on-site construction from September to October 2025. Structural LOD 400 and plumbing LOD 300 models are taken for this simulation. The following table shows the schedule for the elements getting constructed in the coming 8 weeks. This shows the 4D simulation for the construction using Navisworks software up to 8 weeks. In week 1, the column element construction got started and finished in same week. Shear wall construction started in week 2 and got completed in week 3. Rebar fixing activity for beams got started in same week 3. The rebar fixing for beams and slabs got over at week 7 and their casting was completed in a single day of the same week, which was 14/10/2025. Fixing of plumbing elements got started in week 7 and was finished in week 8. Construction is not pour-wise but is happening element-wise, with each slab cycle taking 50 to 60 days. You can scan the QR to see the 4D simulation video in Naviswork. Here 4D simulation using Synchro is provided up to 7 weeks for architectural and structural elements. The column construction was finished at the end of week 1, shear wall construction at week 3 and rebar fixing for beams and slabs almost completed at week 6, with its casting getting completed on 14/10/2025 of week 7. Similarly, scan the QR to view the 4D simulation video for this. On comparison between Synchro and Naviswork, it was observed that appearance of the output can be highly customized in Synchro, since the rebars were having better appearance in Synchro than in Naviswork. Coming to use case, we have taken the use case as per the site major challenge in the construction, which was the trapezoidal PT beam. Because this building has been given for rental purpose, this commercial building has to avoid inner columns in the floor area and need to reduce the span area. The structural consultant decided to go for trapezoidal shape to equally transfer the load among the structure, but the construction crew struggled to reinforce the complex trapezoidal beam and lay tendons by only interpreting the 2D drawings. The table mentioned here shows the bifurcated schedule for trapezoidal PT beam construction. Introduction of 3D rebar model 4D sequence along with the color-coded formwork panels eliminated ambiguity and sped up the work. Now comparing ICP with the traditional approach. During project initiation phase, ICP uses early standardization and definition of roles or requirements and BIM execution plan to mitigate risk. During design development phase, ICP uses integrated structured processes like MEA, LPS for design and clash detection to fill coordination gaps and to detect and resolve clashes early, saving significant costs. In pre-construction phase, ICP uses automated quantity takeoff to generate a precise bill of quantities and planning tools to reduce material waste and achieve savings. During construction planning phase, ICP uses 4D and 5D visualizations to improve constructability, reliability, and financial control. Finally, during the construction execution phase, ICP uses structured methodologies like LPS during execution to maintain schedule reliability and drive continuous process improvements. Now coming to the conclusion. MEA addresses inconsistent accountability across different design disciplines. It establishes clear responsibilities for model element ownership and accuracy. This successfully minimized delays caused by late or incomplete contributions from the consultants. Now, in LOD versus LOS, the LOD-LOS mapping provided clarity on the level of detail and level of informations required for model elements at each project stage. This planning improved transparency in tracking progress through the use of defined milestones. Now coming to the quantity takeoff, the automated quantity takeoff using BIM was performed and the results were compared against manual quantities. The comparison revealed the differences between manual and BIM-based quantities, allowing the team to estimate and compare the cost of quantities from each method. Now in 4D simulation, the construction schedule data was linked with the 3D model elements to create a simulation. This enabled realistic sequencing and made specific issues like PT-beam constructability issues visible through time-based visualizations. Additionally, the color-coded Kaizen elements improved the method clarity needed for formwork identification.